All right, let's take a look at this problem. As I as I do make these videos, you can't hear it, but I listen to the Bob and Tom show, and right now they're being pretty funny. So sorry about that. Here we have an exponential equation, and the idea is that we would like both sides to have the same base, so that we can use this property of exponential functions that they're a one-to-one function. So the 5 is fine. I like that. I'm going to leave this base of 5. I want the other side to have a base of 5. All right. So 1 over 25. Well, 1/5 times 1/5 is 1 over 25. So I've almost has a base of 5 here on the right hand side. Instead of 5, it's 1/5. What if I have a way to flip that fraction? What if I can write this base as 5 divided by 1? Well, then I'd have the base of 5, and that's what I want. And I can justify flipping this fraction if I change the sign of this exponent. A negative exponent never makes your answer negative. It just changes the, it just flips a fraction. It takes a reciprocal of your base. So now I have the same base on each side. If the numbers are the same, that's what this equality, whatever number this represents, which both of these sides, this side was 1 over 25, and the left-hand side is also 1 over 25. You can think of it as written in disguise. Um, and so they're both equal to both sides of this equation, or 1 over 25. Uh, and if the number's the same and the base is the same, the exponent has to be the same. So this, we don't say that the bases cancel, but I know that's what students think, and that's what they say, as much as I try to get you to recognize that the justification from this equation to this equation is that it's a one-to-one function. I know that in your mind you're sitting there saying, hey, the fives cancel, but that's not the correct mathematical justification. All right, so we have a quadratic equation. Of all equations that you've solved, you're probably most familiar with a quadratic equation, just because you see it in Algebra 1, you see it in Algebra 2, you sometimes see it in geometry, and we've done it in here. So, I mean, you have a lot of experience with solving quadratic equations, equations that have the largest exponent being 2. So here, we want to get this in standard form. We always want to get it to equal 0. And um, the king of solving quadratic functions is the quadratic formula. But we know from experience that in general, if you can factor this, it's a much quicker solution. And your Algebra 1 teachers got together and they came up with a method that they refer to as the X method to help students factor trinomials. The middle term here is negative 3x, and you place that at the bottom of an x. And up at the top of the x, you take the first term times the last term. And so now you want to play around with and come up with two values that when multiplied together give you positive 2x squared, but when added give you a negative 3x. So it doesn't take much effort to recognize that negative times negative is positive, and that 2 times 1 is 2, and that when you add these together you get negative 3x. Now, the real power in the x method is when this coefficient is a composite number, when it's a big number and it has lots of different factors. When it's 1, you don't necessarily have to make your table, because you can just use this negative 2 and negative 1 and come over here. Since to get 1x squared, that's just x times x. There's no other combination that we can use to get us this x squared. So now we've got minus 2 and we've got minus 1. So now we need a way to split this one equation into two equations, and there's a theorem that's referred to as the, generally it's something like the zero product theorem, that says if you have a list of numbers, that you're multiplying these numbers together, and if the result is 0, then at least one number in the list has to be 0. One or both or all of the numbers has to be, there has to be a 0 in there somewhere. So either x minus 2 is representing the number 0, or x minus 1 is representing the number 0. And then the inverse of subtracting 2 is to add 2 to each side, or you just take that negative 2 and change sides. When it changes sides, it changes sign, and this becomes a positive 2. And the same over here. If I take this term, the minus 1, and move it to the other side, it becomes a positive 1. So here's my two solutions to this equation. For exponential equations, I don't have to worry about extraneous solutions. So I could take the time and effort to check them, but it's not part of the technique. It's not part of the solution and how we solve it. It may be good practice for some people to kind of check their work, but the technique doesn't require it. So hey, I hope that helps, and I'll talk to you later.